Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. You can recall that in the last couple of lectures we have learned what are the different types of R commands which we are going to use in the further lectures, and then we also learned that how we have to prepare our data so that it is compatible to work in the R software. And now we have enough background, and now we are ready to start our discussion on the exploratory data analysis in data science. So, in this lecture, I am just going to explain you that what is actually this exploratory data analysis. We talk about EDA, but what is the objective? Why we are doing it? What are the different objectives which we want to achieve? And everything has to be done on the basis of the data only. So in this lecture and in the next lecture, I will try to give you a brief background about EDA, and I will try to introduce you with the basic fundamental, basic philosophy and what are the steps which you need to follow while you try to conduct the exploratory data analysis, that is EDA. So let us begin our lecture and try to understand the basic fundamentals of EDA. The first thing comes over here, that whenever we are talking about EDA, that is exploratory data analysis, we are talking about essentially the statistical analysis. What is statistics? Actually, statistics is a science of turning data into information for decision making. You can recall that in the beginning we had discussed that whenever we want to take any decision, it is always a better idea to take the decision on the basis of data, because data never speaks lie and data speaks always the truth. It is only our capability that how much truth we can dig out from the data. So the collection, analysis and drawing inference from numerical fact referred to as data, right? And this exploratory data analysis, that is EDA, this is a starting point for knowledge discovery on the basis of data. And if you try to take any decision without using the data or without basing your decision on the data, then people will not have faith on it. For example, in case if you say the bank rates are higher, nobody will understand it. But if you tell that, okay, the bank rates are 7% annual, then people will understand what is the meaning. Similarly, if you say that the temperature is very high, it may not really convey the real meaning. But if you say that today the temperature is more than 45 degrees Celsius or the temperature is 47 degrees Celsius, then you understand that how much is the heat in the atmosphere. So that is why it is very important to base our decisions on the basis of data. And if you want to know whether the temperature is high or low, then that means you need to collect the data for some time on the temperature, and then you try to tell people that the temperature is high and people will believe on your decision. So this data is a very important source of information. Data has only one problem, that data cannot speak, data cannot listen, data cannot understand our language. But data has enormous information inside it, which is hidden inside it. And our job is that how should we use our statistical tool so that we can understand the language of data, we can understand what data is trying to communicate it to us, and how we can convert the information in such a way which can be used for decision making. So whenever we are talking about exploratory data analysis EDA, then EDA is the first step which is executed when the data comes before us. And the first job is that we want to understand what data is trying to say, what are the different characteristics of the data, what type of information data is containing. And in order to do such analysis or to get such type of information, there are essentially two aspects. One is graphical aspect and other is analytical aspect. And there are several components and tools in this graphical and this analytical aspect. For example, in case if I try to discuss the graphical tools, then there are various types of plots and graphics are available, like as two-dimensional, three-dimensional plot, scatter diagram, pie diagram, histogram, bar plot, stem leaf plot, box plot, violin plot, heat map, tree map, etc., etc. And our job is, depending on the requirement, depending on the objective, we have to decide that which of the graph is appropriate for us. Right. Each of these graphs has a particular philosophy that what type of information it will give to us. And depending on the objective, we have to decide that what type of information do we need to fulfill the objective, and then which of the graphic is more suitable for us to give that type of information. There can be one graphic, or there can be more than one graphic that can be employed for the same objective. That's a different aspect. But this is only we who have to take a call that which of the graphic is useful for us given the objective. Next aspect is analytical tools. Analytical tools in EDA, that means they are going to give us the information in terms of some numerical values. Whereas the graphical procedure, they try to give us some plots, graphics, etc. And we have to look, and then we have to use our judgment to understand those graphics. Right, it is just like doctors looks at the ECG of a person to decide whether the heart is healthy or not. Right. So similarly, analytical tools, they also try to address several aspects of the data, and for that there are various tools. So first, foremost usual objective in the EDA is that people want to study central tendency of the data. They want to study the dispersion in the data, that how much is the variability. And in order to understand the information hidden inside the data, they use different types of tools. For example, if they want to study what is the central tendency of the data. Central tendency means what is the average value, around what value the data, most of the data is concentrated. So there are different tools, for example, mean, that is arithmetic mean, median, mode, geometric mean, harmonic mean, quantiles, etc. They are different tools which gives us the idea about the central tendency of the data. Similarly, if we want to measure the variation in the data, there are different tools like as variance, standard deviation, standard error, mean deviation, absolute deviation, range, etc. And they also give the information about the variability in the data. And once again, I would say it is our decision that which of the tool is to be used and which of the tool is most appropriate to give us the dependable and reliable information about the central tendency and variation in the data. Then we also want to understand the structure of the data, and we want to study if there are any relationships in the data. So in order to understand the structure of the data, we try to study whether the data is symmetric around certain value, or the data is skewed, or data has a kurtosis. Symmetry means, for example, if I try to show you here, if the curve is like this, which is the symmetric, and whereas if you try to see if the more data is concentrated on the left side and less data on the right hand side, or there is a less data on the left hand side and more data on the right hand side, this is called skewness. So we want to study this type of behavior of the data that was really happening. And then after that, we would like to study if there are any relationships in the data. For example, if I say during the summer time, if the temperature increases, then the consumption of water also increases. So there is a sort of relationship. So we want to understand if the data has got say any sort of relationship, and if the relationship is there, what is the nature, what statistical model can be prepared to depict the relationship, and so on. So for these things, we try to study the aspects of correlation coefficient, rank correlation, multiple correlation coefficient, partial correlation coefficient, correlation ratio, intra-class correlation, linear regression, non-linear regression, and many more things. So whenever we are getting the data, then these are the simple objectives which we want to execute. And all these tools, either graphical and say analytical, they are the part of EDA. Right, and this is what we are actually going to do here. We are going to study all these essentials of EDA in our forthcoming lectures, that how we can create different types of graphics, how we can measure the central tendency of the data, how we can measure the variation of the data, how can we study whether the data is symmetric or not, or how can we find and study if there exists any relationship in the data or not. So these are our basic objectives which we are going to study in this course actually. Right. Whenever we are going to get any data and we have certain objective to fulfill, this is only actually we who have to decide that whether we want to find here the mean or the variation, whether we want to study here the symmetricity in the data or we want to study the linear relationship in the data. This is only you who is going to take a call. This is what you always have to keep in mind. For example, as a patient, whenever we go to the doctor, we simply say that, okay, I have a pain in my stomach. It is only the doctor who has to take a proper call that which of the medical tests the doctor is going to recommend for the diagnosis or which medicine the doctor is going to recommend for us to control the pain. Right. I can only tell that, okay, I want a medicine for my stomach ache. So similar is the story in statistics and EDA also. Whenever somebody is trying to conduct an experiment, usually they are not from a statistics background, they are from various background, but they have certain objective in their mind which they want to fulfill, and with that objective they come to the statistician and they simply ask the question that, can you please verify whether my findings are indicating this thing or not. And now this is only the job of a statistician who has to decide that to fulfill the objective, whether the person needs to be given the information on the mean, variation, skewness, kurtosis or regression or a combination of them. And in order to do this thing, which of the graphical tool can be used, which of the analytical tool can be used, and in fact, a combination of them also. So whenever we are going to handle the data, the first question which I have seen, which is very common, people want to know which of the tool to be used, graphical or say analytical. My recommendation is that we have to use both types of tool depending on the objective. Graphical tools provide us a visualization, the first-hand information. For example, if I try to plot here a data between two variable x and y, which is here like this, and if I try to plot another data between x and y, which is here like this. So do you think that the behavior of the data in both the cases they are the same or different? They are different. But yeah, what will be the mathematical model depicting the relationship between x and y? This is very difficult to say at the moment, but at least I can say that the relationship between the figures 1 and figures 2 are going to be different. So these graphical tools gives us a visualization of different aspects of this data which are hidden inside it. Similarly, the analytical tools gives us the hidden information in the form of some number. So they give us the quantitative information. And in general, in my experience, I have seen that both the approaches work together and they are inseparable. And that you will see in the forthcoming lecture whenever we are trying to develop different types of, say, these tools, either graphical or say analytical. You will see that they are trying to indicate whatsoever hidden inside the data and how they are going to depict it. This is what we have to exactly learn, right? So actually, both these graphical and analytical tools, they work together in a system of, say, interconnected process, right? Sometimes the mean is higher, sometimes the variance is lower, sometimes some plot is indicating something, some plot is indicating an outlier. So both of things work in a systematic way. And variation exists in all the process. This is the key, this is the soul of statistics, and that is the basic difference between statistics and mathematics, that statistics always said there has to be some random variation in the data, whereas mathematics is an exact science. So understanding the extent of variation, and we aim that we have to use a tool which is giving us an answer in which this variation is minimum. or we always try to develop a tool which can reduce the variation and give us the better value. And these are our the points of success. For example, if you ask me that, okay, if I ask you that how much time are you going to take from your home to your college, and if you say that, okay, it is going to be from say 20 minutes to 5 hours, then the variation is very high. But on the other hand, somebody says it will be 20 to 25 minutes, then definitely the answer in the second case is more reliable and people will prefer it. Or in a simple way, I can say that the variation in the second statement is much less than the variation in the first statement. So this is the same objective in statistics also, right? And the main objective is that we have to use this information which is obtained by the descriptive statistics like as the tools of central tendency, to tools of variation, and say graphical tools, and we have to combine all of them together so that a meaningful conclusion can be reached and which can depict the information which is hidden inside the data and which is in conjunction with the objective of the statistical analysis. Right. Once you have obtained such graphics or such numerical values of the statistical tools, then the proper interpretation of inferences is very important, or you want to draw statistical inferences. For that you want to make proper interpretation. This is very important, and those statistical inferences are drawn from the data only. When we are talking about the data is generated by a process. Whenever we want to study any objective, we try to conduct the experiment, and then based on that experiment, we try to generate the data. And or I will say that there is a process which is governing the experiment, and that process is generating the data. So this data generating process can be non-deterministic or this can be random, right? So, but the first question comes here, why should I collect the data? So, there are different reasons to answer this question. First of all, I would like to verify the theoretical findings. For example, sometime I have a belief that this in this experiment this is happening, and for example, in economics I have some principle that okay, if this happens then this will happen. But I need to verify it whether my hypothesis is correct or not. So that is why we want to collect the data on that process, and we would like to see that whatever theoretical framework I have created, whether the data is really going to follow it. So I want to verify my theoretical finding. And we want to draw our statistical inferences on the basis of the collected set of data. Because whenever we are trying to conduct an experiment, that means there is certain objective behind it based on which we have planned the experiment. So the data which is getting generated from that experiment is going to explain what is happening inside the experiment, right? And for that we try to develop the statistical models also, and such statistical models are further used for policy decision, classification, forecasting, etc. Right. Now, if I try to see that if you want to conduct an EDA, then what are the steps? The first very important step is that you need to identify the objectives of the statistical analysis. Why are you trying to do this? And suppose it is as simple as that, as if somebody is having a problem in the heart, then the doctor recommends ECG. But if somebody has got a fracture in the bone, then the doctor recommends X-ray or say MRI. So that means the doctor knows what is the objective, that they want to know whether the bone has been fractured or not, and based on that they want to decide whether they have to go for ECG or for an X-ray. So the similar is the story in data analysis also, that you have to identify your objectives. Now, based on that objective, you have to collect the data on the relevant variables, right? It is something like this. If you want to find out the average age of the students in a class, then you need to collect the data on the ages of the student in that class only. So how to get such a data? Such data can be obtained from the laboratory experiment, which is more or less a controlled environment, survey, primary data, secondary data, and many other resources. Once you have received the relevant data, I am emphasizing relevant data, then you need to decide what is the appropriate statistical tool which I want to use on the data, whether I want to find out arithmetic mean or variance or correlation coefficient or something else. And based on that, we have to ensure that we are getting the correct, valid and meaningful interpretation of the result. This part is coming from the practice also, practice and experience also, right? And now we are talking about two words actually, data and observations. So what is observation? The units on which we measure the data, that is called as observation, right? For example, if I want to know the number of persons, number of cars, monthly expenditure on food, then these are our observations, right? And whenever we are collecting our observation, the observations are collected from a population. What is a population? The population is a collection of all the units, right? For example, in case if the objective is to find out the average age of all the female students in class 10 in a school on the basis of a sample, then the population is consisting of all the female students in class 10 in that school, right? Similarly, if my objective is that we want to know that how many female employees have salaries more than the respective male employees in a company on the basis of a sample, in this case, my population is going to consist of all the male and female employees in the company. Similarly, if my objective as which among young and older people uses Google Maps more, so in this case, my population is going to be the collection of all the young and old people in the world, from where we are going to collect a sample. So now we are talking about sample. What is a sample? A sample is a subset of the population. You try to take a small fraction from the population, and one thing what we have to keep in mind, that this sample is always have to be a representative sample. What do you mean by representative sample? Representative sample means all the characteristics which are present in the population are also present in the sample. For example, in case if I say, suppose if I have here a population where suppose there are 70% male and 30% female. So when we are trying to draw here a small sample, then we expect that more or less in the sample also the 70% approximately will be male and approximately 30% will be female. Or I would say if you try to take a handful of sample of the wheat from a 100 kg bag of the wheat, then you expect that if there are some spoiled grains in the 100 kg wheat bag, then the same proportion of the spoiled grains will also come into your sample. The sample may consist of only say 20-30 grams of the wheat out of 100 kg bag. So the selection of observation in the sample from the population is always made in such a way such that the sample is representative. And the fact is this, we always use the word sample, but whenever we are using the word sample, it is indicating that it is a representative sample. So this is what you always have to keep in mind. So the next question comes here, that if you really want to have here a representative sample, then how to get it? So I can tell you here that in statistics we have an area which is called as sampling theory. So in sampling theory, there are different types of sampling schemes which explain us that under different type of conditions, we can get different types of representative sample. So for example, if the populations are different, then if you want to have the representative sample, then these sampling techniques explain you that under what type of condition or under what type of population you can use which of the sampling scheme such that you get a representative sample. So if you, I'm not going into the details of the sampling theory, but it is just for your information that there are various types of sampling scheme, like a simple random sampling, stratified sampling, cluster sampling, systematic sampling, multi-phase sampling, multi-stage sampling, and they are all actually used to get a good sample, right? So if you try to see here, and then these different schemes are used under different types of, say this scenario. Well, I'm not going to explain here all the details about this sampling scheme, but if you wish, you can go through any sampling book and then you can have a look that what are the different conditions under which we can use a particular type of sampling scheme. So that will ensure that your sample is random as well as it is representative. The sample has to be random, that we will see in the later stage that it is a requirement of our statistical tool, right? So now I stop here in this lecture, and you can see here this was a pretty simple lecture, and in which I have tried my best to give you an overview of EDA. People talk about EDA, but then what exactly is to be done in a systematic way? This is what my objective was to explain you in this lecture. I would say you just think about it, try to keep these things in mind, and try to imagine that if you want to know the answer of any question, what are you going to do? How are you going to collect the data? Suppose sometime you hear that, okay, in this season the viral fever is spreading. How do you know that whether the viral fever is spreading or not? So the simple reason is that you start hearing from many people that they are getting affected with the viral fever, but not everyone is going to be affected by the viral fever. Now you take a decision whether the viral fever is spreading or not. How do you do it? Just try to think about it. That's a very interesting process. And similarly, if you try to observe the phenomena which are happening around you, and every day, every second, every minute you take a decision. How do you take that decision? If you try to realize God has given us the power, and we immediately collect the data inside our mind and we try to take a decision. So you try to think about it, and I will see you in the next lecture with more description on EDA. Till then, goodbye.